Good morning, everybody. Welcome to yet another 2015 Q3 accreditation training for EMC sales and EMC SEs. Today's topic is Cloud Foundry. You all know this as a Federation asset, but what the heck is it? What does it really do? How does it work? What are the parts? I hope you guys really enjoy this. My name is Matt Cowger. Myself and my colleague Jonas Roslin prepared this presentation for you. If you have any questions, please feel free to reach out to us on Twitter or on email, and we'll be happy to answer questions. Let's get started right into it. Cloud Foundry is a PaaS, a platform as a service. So what's a PaaS, you say? It's fundamentally a set of services that provide a platform for people to run applications without really focusing on the infrastructure required for that application. If you think about that, what that means is we get to focus on the code instead of operating systems and VMs and runtimes and all the things that really are just a way so that we can do what we want to do, which is to run our code. So what kinds of problems does it solve? Fundamentally, managing operating systems sucks. It's painful, it's difficult. Every operating system has its own way of doing things. Ubuntu is a little bit different than CentOS, is a lot a bit different than Windows. And ultimately, you don't want to manage an operating system. You want to manage and run your code. Managing runtimes is a very painful process. And by that, I mean deciding if you're going to install PHP 5.4 or 5.3 or Python 2.7 or Python 3.4. How do you make that decision? And how do you make sure that those don't override each other? Managing deployment of dependencies of your applications is very, very painful as well. How do you make sure that you don't have conflicting versions of various plugins and modules and libraries installed? How do you make sure that your applications running on the same server are isolated? That's to some degree possible with something like VMware or KVM or OpenStack, but that's a little heavy to run an entirely separate set of operating system for every individual application just to get isolation. It'd be nice if there was a better way. And then managing deployment of all of that infrastructure is also really, really painful. Managing large numbers of servers, while things like Puppet and Chef and Ansible exist, and to make it easier, it's still not easy and it's not great. And then how do you manage deployment of your code and things like that? Cloud Foundry fundamentally solves all of these problems. So let's think about what it takes to deploy and scale an application on something that's a more traditional infrastructure as a service, as opposed to platform as a service. And I'm thinking about things like EC2 and DigitalOcean and Google Compute Engine and even our own enterprise hybrid cloud. So the first thing we do is we deploy a virtual machine. That's the easy part, right? That's handled by that infrastructure as a service. But how do we keep track of that? Is there a CMDB that we need to update? What kind of code or scripting do we need to write to make sure that happens? Or perhaps there's a manual process that somebody will forget someday. Next, we need to secure that VM. We need to do things like enable logging or enable Active Directory integration or something like that. Or we need to write some Puppet or Chef kinds of code to do that automatically for us. That's again another task that can be done either manually or we need to write and maintain some code for. The same is true for managing Python or Java or whatever. How are we going to manage that runtime? What are we going to manage it with? Are we going to install it with RPMs, with tarballs, with Windows packages? How are we going to make sure it's up to date consistently? How are we going to install dependencies? We have to do that. Are we going to write some scripts to do that? How are we going to install our application? Are we going to upload a tarball or an RPM of our application? Are we going to download it from Git or install it from an MSI? What code are we going to write to manage that? And then we need to start our application. How do we start it? How do we make sure we have enough copies of it running? Are we going to use a job engine? Are we going to use something like Monet? How are we going to ensure that it always stays running and that we always have the right number of copies running? All of these things are doable on an IaaS today. It's just that you get to write all of them and manage all of them yourselves. And while that is certainly something that's doable, if you think about your average company that's doing realty or handling baseball games, that's not their focus. Their focus is not to reinvent all of these things. that fundamentally already exist. Cloud Foundry handles all of that for us. Okay? When we deploy a new application, all we need to do is cf push app name. If we want to add more copies of that app, it's one more command. And all of those things that I just mentioned are actually handled for us under the hood. That's pretty cool. Let me show you what that looks like. I've got a very simple application here that just basically displays a hello world. And so what I'm going to do right now is I'm going to push this to Cloud Foundry by doing cf push, then the name of my app. I'm going to call it mcalger test. So what it does, it takes all of the code that's here in my application, creates an application record for it in the platform as a service in Cloud Foundry, binds a URL to it so that we can actually access it from the outside world, and this is of course fully configurable, uploads all of those files into Cloud Foundry itself, and then proceeds to install within a little bubble, its own little bubble, a copy of Python, because this application happens to be a Python application. And then it goes forward and installs all of the dependencies that I've stated are required for this application. All of this is happening automatically. I didn't tell it that I needed to do any of this. It simply identifies this from my code. Finally, once we have this set of three things, the application, the runtime, and all of the modules that are required for it, we package all of those up together into something we call a droplet. And this is basically just a set of files that happens to be about 37 meg, as you see, that correspond to this particular version of my application. We take that droplet and we store it somewhere safe. We call this the blob store. And then we go and we actually put it on a server somewhere and we wrap a container around it. And yes, if you've heard of things like Docker and Rocket, this is the very same kind of container. And we then get all of our process isolation and prevent anything from interacting negatively with our application. And so in just a couple minutes, I've got my application up, running, and serving out a relatively boring web page. So this happens very easily, very quickly, and it makes it so that our application developers don't have to worry about any of the things that are really painful. So let's talk about the parts of Cloud Foundry. There's a number of pieces that correspond to it, and these are actually pretty similar to any platform as a service. Within Cloud Foundry, we've got about 8 core pieces. The Cloud Controller and so on and so forth. We'll go through each one of these and I'll talk about what they are very briefly. The Cloud Controller is not much more than an API layer. It's what lets us interact with our Cloud Foundry cloud in a consistent fashion so that we can use things like Cloud Foundry command line tools, or we can use things like APIs from Python or Java to control our entire cloud in a consistent way. And it's what lets us interact with it and see the various things that exist. We have UAA, which is an authentication layer that lets us make sure that only the right people are doing the right things in the cloud. Some people should be allowed to make any kind of administrative change, and some people should only be allowed to see what's running, for example. It can use internal authentication or use an LDAP backend, and this is actually a space where EMC has actually contributed some notable recent work to the project in a completely open source fashion. Diego is actually probably the most interesting part of the application, or the Cloud Foundry system, because when you think about what's happening, I just uploaded my application and I said we put a container around it and put it on a server somewhere. But I need something to do that. I need something to manage that container, to choose where to put it, that's called scheduling, to manage the creation of that droplet, that set of files that correspond to my application, and then also make sure that it's always running. That is the job of Diego, and it controls all of the placement of containers and managing where they're running and that they are running and all of those sorts of things. And it's actually the center of a significant recent focus on rewriting part of Cloud Foundry, and that is the Diego Elastic Runtime. Diego also supports things other than just raw code. If you wanted to run, for example, a Docker container within your Cloud Foundry environment, you could do that with Diego as well. So Diego is very, very powerful and allows us to run pretty much anything across a large-scale cluster without worrying about individual placement. For those of you who are familiar with VMware and have seen things like VMware HA and VMware DRS, Diego is performing very, very similar functions in terms of load balancing and keeping applications running. Once we have all these applications and we've perhaps created 20 different applications, we need to make sure that our logs are easy to read and easy to review. We don't want to have all of the logs for every application in one place and have to try to sift through that. So the Loggregator component actually is a component for delivering application log output, collating applications together as needed, and then delivering them off to another platform for analysis like Splunk or Log Insight, or for just looking at them like in the example I have below. So we also get great logging out of our Cloud Foundry system. Further, we also need a way to take requests in from the outside world and then send them off to an application that's handling that particular URL. Now, it's entirely possible that I might have just one copy of that application running, but it's probably more likely, especially with modern applications, that I would actually have multiple copies running to handle things like additional load or failure scenarios or something like that. And it's the job of the Go router to accept requests and pass them off to the relevant location. Now, I will say that the router can be replaced by other load balancers if needed, although that is not entirely common, but it can be done for certain kinds of scenarios. Build packs are the things that provide the basis for running an application that are language specific. So let me give you an example. Python has a set of files that correspond to the base Python language, as well as a common way for installing requirements. It's a method called pip. The Python build pack provides not only that runtime, but also the things needed to install the requirements as they go. Ruby, Java, they all have similar ideas, but they're implemented differently, and so they all have individual runtimes and therefore individual build packs that handle installation of these things as necessary. What's nice is that we can build a build pack for pretty much any language we want. There are build packs for Ruby, Python, Java, any of the common languages. There are even some for uncommon languages like COBOL and Fortran. And some recent developments actually involve even build packs for running Windows applications on Windows systems within Cloud Foundry, including applications built with Visual Source Studio or something like that. So if you can run it on a computer, you can probably have a build pack for it. That's the nice thing about Cloud Foundry, is that it is not opinionated about what language you run. You can run whatever language you want. Because we have these applications, we have to fundamentally understand that no application is an island. Everything eventually talks to some external resource, whether that's a database like MySQL or Oracle, or whether it's a modern NoSQL database like Redis, or whether it's a message queue like ZeroMQ or RabbitMQ. Cloud Foundry has a native understanding that this happens and that we need to bind a service, say a database for my website, to the application that actually creates the pages for my website. And Cloud Foundry has a native understanding that we bind an application to a service and that they need to go together and provide the relevant things like host name and usernames and passwords to those applications in a secure and safe manner. So Cloud Foundry handles this for us and can even go so far as to create databases on the fly as needed. Now, the last piece is the ability to build up all of that underlying physical infrastructure to run these virtual machines, to run these containers and applications that we're running. We need something that can take a raw VM or raw host and turn it into what we need. These raw hosts are called cells, and Bosch is the tool that is responsible for requesting these raw hosts or VMs from the relevant infrastructure as a service, whether that's vSphere or vCloud Director or OpenStack or AWS, they're all supported, to build the virtual machines, put what it needs on there, It's currently based on Ubuntu with some other stuff, and get it ready to join the cluster. Some other things that are coming is that we're working on Cloud Foundry for bare metal so that you don't even need a VM layer. And there's also working on adding support for VMware's new Photon container-based OS. If you want to know more about container OSs like Photon and CoreOS, I'd recommend you check out the other Q3 accreditation training that I did on things like CoreOS. So now we have all of the tools that we needed together to build an infrastructure and manage entire sets of applications without ever worrying about what's underneath there. And that's a very powerful thing to do. Bosch is also responsible for things like long-running processes and tasks and upgrades of the infrastructure in such a way that we don't bring anything down, which is really, really, really handy. So all of these problems are fundamentally solved problems, and they're solved by CF and all of the projects that go along with it. So if you're interested in CF, you're interested in seeing how we can really get great ability to manage applications like I just did and delete them as we go, just like that, please take a further look into Cloud Foundry, contact myself or Jonas, and we'll be happy to show you more. It's a really, really neat technology.